Good afternoon. My name is Othmar Frey. I'm a senior scientist at Gamma Remote Sensing and in Zurich. And today I'm going to present our recent developments on mobile mapping of surface displacements within novel UAV and car-borne InSAR system at L-band. Since the time is very short, I also included my email information here. So if you want to get in touch, if you have any questions, please don't hesitate to contact me. So what is our motivation to do mobile mapping using a UAV or car-borne SAR InSAR system at L-band? L-band has some complementary properties compared to quasi-stationary Ku-band terrestrial radar systems in terms of temporal decorrelation in natural terrain and different sensitivity to surface displacements. Also, UAV-borne and car-borne SAR data acquisition allows a long synthetic aperture. This means we can achieve fine resolution even at L-band. And UAV-borne systems also allow flexible choice of the line of sight direction. This is an asset, of course, for displacement mapping, but also other applications. Our target application is displacement mapping, geohazard mapping, glacier flow mapping, and we think that there's a high potential for adoption by the geohazard and landslide community. And then, of course, there are also other applications such as SAR Tomography and many more you can think of. On this slide, you see a short overview of our compact L-band SAR system. It has up to two alternating transmit channels and 4 simultaneous receive channels. For more details, please be referred to this table here. As a processing approach, we use a time domain back projection approach that is able to cope with nonlinear platform motion in combination with topography. So we have a strict handling of the 3D geometry with this approach. It's implemented on a GPU for fast processing. We started to do car-borne L-band, the InSAR campaigns for glacier velocity measurements in 2018. Here you see the scenery at Sustenpass in Switzerland, and we can see the SAR imagery, the InSAR interferogram and the coherence map, as well as the final displacement map with the displacement of the glacier mapped over here. Then we started to do UAV-borne L-band SAR campaigns in 2019, together with Aeroscout, who is operating this UAV helicopter here. This is a short overview of the scenery and some imagery, as well as short-term interferogram and coherence, as well as some close-up of the radar imagery. In this video, you see an overview of the scenery where we were acquiring the data from the valley up to the hillside. We could show that we get good repeat pass performance for short-term and zero baselines. And as you can see here in this interferogram and coherence map, and with increasing spatial baselines, we of course then get some phase artifacts due to height of the trees that are not mapped in the DEM, and as well as the volume decorrelation that is decreasing the coherence. We did some tomography opportunity processing of the data. Here you just see a transect of such imagery with the tomographic focusing here on the upper right-hand side. So if you have any questions regarding that, please get in touch with me for more details. Besides the UAV platform, we also were doing, again, car-borne repeat pass demonstration cases at the landslide in Switzerland that is fast moving here in the background. Here you can see the car driving by and acquiring the data. In this video, you see an overview of the products that are generated in the processing chain to obtain the displacement map, starting with the interferogram, the coherence map that we also get, of course, and then some detrending, filtering, and then the final line of sight displacement map. To conclude our presentation, we could demonstrate that we can obtain good surface displacement mapping from UAV and car-borne L-band systems. We've shown the feasibility of UAV-borne SAR tomography as well. And we think that we have a lot of further work in various directions. We are only at the beginning of exploring the full potential of this agile mobile mapping platform. If you have more questions, please get in touch with me. Also look at our website. Thank you very much.